Hi guys, Shouvik here. Welcome back to our YouTube channel. Yeah, today we will solve the question 2161 of Leetcode, that is partition array according to the given pivot. So these questions it is tagged as a medium difficulty, but I don't think so. That is a medium difficulty. It is going to be a easy difficulty if we are not restricted to use the big of one space. And I have tried spends couple of hours on that to solve it on big of one space complexity, but yeah, then on the discuss sections and other resources I found that it is still now we are not able to solve it on big of one. But yeah, if you guys have any suggestions to any alternate solutions where you are able to solve the question with big of one space complexity and along with time complexity of something like n or n log n something, because the constant is pretty high, that is 10 to the power 5, so you have to solve it uh, in the complexity range of n or n log n on the big atom. Yeah, so let's just quickly go through on the questions. It is so on these questions, like we are given a zero index integer array where uh, with name as nums and the integer pivot, and what we have to do, rearrange num such that a few conditions they have provided that is going to be met. The first conditions they have provided, like every elements lesser than pivot appears before every elements greater than pivot. So like pivot should, whatever the elements which are lesser than my pivot, that should become first, and whatever the elements greater than pivot, that should become after the occurrence of the pivot elements in the resultant array. And every elements equal to the pivot, it appears in between the elements less than and greater than the pivot. So like if we have, so this statement basically provided, like if we have like multiple occurrence of pivot elements, then that elements, like if we have 5 occurrence or 2 occurrence of 10, yeah, which is there in the test case. I will come on the test case, but so on that case, like that both the tens can be grouped in between their ideal place, and first group should be the lesser and next group should be the greater elements. And but that is not mandate that the lesser elements who is lesser than pivots, that should be like in the sorted, that should be like, that should be in internally they have sorted, like let's suppose we have pivot as a 10 and lesser elements are 953. As per the questions, we don't have to sort them, sort 953 which are lesser, we can put them the order they have appeared in the actual array, and similar is going to be for the greater elements. Yeah, so on the point 3 you can get this what I just mentioned you. So the relative order of the elements less than the pivots and the elements greater than the pivot is maintained. So that is what I told. Like here you can see that 953 which are lesser than my pivot, the pivot is 10. So out of them you can see like 9 occurs first, then 5 occurs in the actual array, then 3 occurred, and the same order they have vended out on the resultant array. And same is for the greater elements. So 12 is greater and then 14 is greater, and they have followed the order they have appeared in the actual array. Yeah, so initially I have thought, like initially with the tags of the mediums, and also I have as name with the pivot, like there is a very popular algo we have it in the market, that is of like quick sort, where we have to keep on partitioning the actual array, and when we basically merge the partitions on the merge steps, we have on every steps we choose an elements, arbitrary elements as a pivot, and try to put it to the correct place of it. Yeah, so I have tried with this to make it uh, work on big of one space complexity, but yeah, not able to do so. So I'm just quickly explain what I have tried and what is basically the problems for which we are not able to do so because of the third constraints, third conditions in the question. Yeah, so let's suppose, let's take the example as it is. So we have that 9 9 5 10, and if we try to basically follow the same algorithms which is vended out by the quick sort algorithms in the partition steps. So it is something like we have something like, let's take a smaller example only. Let's just take arbitrary example. Let's suppose we have some random elements 3, then 3 is there, then what else, like 7 is there, then 2 is there, and then what, then let's suppose 6 is here, then 1 is here, and then 9 is here, and let's suppose our pivot is this. So the pivot given in the question, let's suppose 7 is our pivot. So yeah, just not to take any greater look on my handwriting, that is going to be very much, I know. Yeah, so on 372, like if I try to follow an algorithms which we will do in quicksort algorithms, we will basically follow 2 pointers. One pointer should be pointing to the first of the elements, and the second pointer is going to be point to the last of the elements. And then what is going to be happen, then we will check, like we will go until, like, so the condition is our should be lesser than j, and we will continue to check, and inside that we will run another while loop where our nums of I, that is the ith elements, is lesser than my pivot, and what, and my I, and my I should be lesser than j. On that case I will go my I plus plus. And similarly while my nums of j is greater than my pivot. So what I am trying to do here, my I pointer, like I is starting from very first and j is starting from very last. So every point I am just going to check the elements which are lesser than my pivot. If I am encountering an elements in the via I pointer which is lesser than my pivot, so that is fine. We will don't do any operations with that element. So we are just so for that we have just do the I plus plus, and similarly we will do here j minus minus. So that is an elements which is smaller than, which is basically the pivot element is smaller than my nums of j. So that is also fine. Like on the back side we have to do the reverse, like the elements is greater than my pivot elements. So this point is fine. Now at the end what we have to do, we have to basically, so my I pointer is pointing to an elements where my nums of I is greater than my pivot, so which is basically not expected. And previous that we will check if my I pointer is still less than j, and if my I is greater than my j and greater than my pivot, and my nums of j is basically pointing lesser than my pivot. So my ideally what should be expectation, I pointer should be always, nums of I should be always lesser than my pivot, and nums of j always greater than my pivot. But that is not the case. That is a violation where actually the 2 pointer is going to be currently lying. So the 2 pointer in the actual partition merge sort of the quick sort algorithm, where we are basically doing the partition part, the 2 pointers I and j is basically lying to a violation point where I and j is violating, like I is going to be a greater elements of my pivot and j is going to be with the lesser elements of my pivot, which is not ideal case. And on that case what we will do, we will basically swap my nums of I and nums of j. So we will basically swap them. Like this way we will keep on doing, and after that when we are done with this, like I pointer is passed on, then after that we will basically doing the swap between the partition elements and and the j pointer, because nums of j, where my j pointer is pointing, because the j pointer on that particular time is standing where basically the elements which is just smaller than my pivot is going to be lying. So we will just swap that element, so that right segment is already followed the formula, and left segments also followed the formula, and pivot is going to be stand at the jth index where it should be. Yeah, so this is the algo, but where it is not working on this case, because but yeah, just a quick reminder, like if we don't know on the quicksort algorithm, then I will share a link where you can go through to understand the quicksort better. Then you can get the gist of what I am trying to say on this particular drawing. Then and after that you can come on this, so that we can do. But yeah, the general idea of the quicksort is we have to find the violation point, and on the violation point we have to just swap the elements, and like this. So if we keep on doing that, then ideally our considering the partition elements is going to be its correct positions. Yeah, so now let me just go through the third conditions. On the third conditions, it is stated that the relative order of the elements which is less than the pivots and which is greater than the pivot should be maintained. So that is not going to be happen, because like if I can show you, like on this diagram only. So here you can see my I and j is initially pointing to 9 and 14, and it is a good case, like I can go further, and j can also uh, downgrade himself, because that is a valid condition. 5 we are fine. 3 we, sorry, I am iterating on the wrong array, on the resultant array. 9, 10, we are good. Let's suppose we have that lesser than equals to check, and now let's suppose we are at 12. I pointer is at 12 and j pointer is standing at 3. Now that is the first case where actually the violation has happened. So on that case we have moved 3 to the beginning, 3 to this point, and 12 to this point. Let me just draw it out so that you can get a better understanding. If I can escape from this, and is there any options where I can basically copy the test case? So that is our test case, and sorry, on this, if I can, oh shit, what it is going to be happen, what I have copied. 9, 12, 5, 10, 14, 9, 12, 10, what else, 9, 12, 5, 10, 14, 9, 12, 5, 10, 14, then 15, 14, 3, 10, 3 and 10. So what I am trying to say, so here you can see, if my I pointer is standing on this place, my I pointer is standing at here, and my j pointer, let's suppose, standing at here, like I at 12 and j at 3, then we are going to do something like this: 9, 3, then what, 5, then 10, then 14, then 3, sorry, not 3, then 12, then 10. Now you guys might argue that this 10 is not going to be put at its correct positions, but yeah, we can do, we will just again run another loop to basically put the elements to the correct position. The pivot elements is only going to be on the wrong positions, other elements is going to be its correct positions. But the third conditions we have violated on this, so that's what I am trying to explain. So here you can see, our, as per the question, if 10 is our pivot, if 10 is our pivot elements, then all the smaller elements who are smaller, 9 is smaller, 5 is smaller, and 3 is smaller. What should be the order? 9 should be come first, 5, then 3. But with this quick sort partition algo, we have like completely distorted that third points. Like 9 came and then 3 and 5. And similarly, these distortions can happen for the greater elements also. So that is the reasons we need an extra space. And you can go to the discuss and learn from the discuss sections, and also from the hints also, like there also it is mentioned that you can, like, can we create some separate group of chunks of list, and to basically maintain the orders. And if we are allowed to do so, then that is not going to be a medium question altogether. So then I think it is pretty easy question then. So what then we have to do, we have to just found out like who are my lesser elements, who are my equal elements, and who are my greater elements. I have created 3 empty lists with this, and then I have iterate each elements of the array and check if my current elements is lesser than my pivots. I am pushing to my lesser list. If it is equal, I am pushing to my equal list. If it is greater, I am pushing to my greater list. And after that, I am just basically concatenate all the 3 lists and return it out. Yeah, so then that is like very brute force based implementation only. The time complexity, yeah, let's jump on the time and space complexity. So we are iterating of the array like one time here. So that is for sure big O of n, and this concatenation operations again is going to be take another big O of n. And on space complexity we are using 3 lists. So but actually if we are sum it all together, and as we are using Python list which is dynamic in nature, for other languages you can use vector or other data structure array list or something, where you can dynamically push the elements. You don't have to statically mention the size. Then the sum of the list is going to be also of big O of n, like the length of the resultant list. The sum of the list is going to be the length of the result provided num list. So the space complexity also like of big O of n, and time complexity is big O of 2n. Let me just write it down for your reference. So our time complexity is, if interviewer asks what is the exact time complexity, you have to say like big O of 2n, because we are iterating one time and the concatenation is taking big O of n time. So please be sure on this part, that is not a big O of 1 operation, this is a big O of n operation. So we are doing so. And space is, you can say it is of big O of n only, because the sum of the 3 list is going to be n only. Yeah, that's all about for today's question. Yeah, thank you guys. Thanks to attend the sessions, and please consider to subscribe to our YouTube channel. We will keep on posting similar industry standard questions on daily basis. Yeah, and let's meet tomorrow. Bye bye. See you.